আমি রেডি হয়ে গেছি, লিঙ্ক দিচ্ছি। রেডি হয়ে গেছে, লিঙ্ক দিচ্ছি জাস্ট। হ্যালো, হ্যালো। হ্যাঁ, হয়ে গেছে।
হ্যালো, হ্যালো।
It is my great privilege and honor to introduce our esteemed resource person for this session, Professor Dr. Jyotsna Kumar Mondal. Professor Dr. Mondal is a retired professor of computer science and engineering at the University of Kolkata and has served in several prestigious academic and administrative positions. He is the former Vice Chancellor of Raiganj University, West Bengal, former Dean of the Faculty of Engineering, Technology and Management at the University of Kolkata for two consecutive terms from 2008 to 2012, and also served as the former Director of IPSC and Chairman of CIRN, University of Kolkata. He has completed his MTech in Computer Science from the University of Calcutta in 1987 and was awarded the PhD degree in Computer Science and Engineering by Calcutta University in the year 2000. With more than 36 years of distinguished teaching and research experience, Dr. Mondal has made remarkable contributions in the areas of domain theory, data and network security, authentication, remote sensing, and GIS applications, data compression, error correction, visual cryptography, and steganography. He has successfully supervised 34 PhD scholars and has published more than 450 research articles in reputed national and international journals and conference proceedings. Recently, he authored the book Reversible Steganography and Authentication via Transform Encoding, published by Springer, which has also been translated into Chinese and republished in China. Dr. Mondal has organized more than 65 international conferences and has served as editor and corresponding editor for conference proceedings and edited volumes published by Springer, IEEE, and Elsevier, among others. His outstanding academic excellence has earned him numerous prestigious honors, including the Shikharatna Award from the Government of West Bengal in 2018, the Vidyasagar Award, the Research Icon Award in 2023 and Academic Excellence Award in 2024. He also holds important professional responsibilities as the ISO World Convener, ISO IC, Governing Council Member IT India, and Eastern General Mentor of IT India. John was supposed to join us offline in our seminar, but due to his sudden illness, he has agreed to join us online today. Today he will be speaking on the topic AI for responsible and sustainable environment, a futuristic model. The chairperson of this session is Dr. Suman Sinha, Associate Professor of Department of Physics, Personnel College. On behalf of the organizing committee, I extend a warm welcome to you, sir. May I now request sir to kindly deliver the address.
Thank you very much. Am I audible now?
Yes, sir.
Okay. Okay. So I'm switching off the video for my connectivity, and I'm sharing my screen. So my PPT is visible. Hello.
Yes, sir.
Okay. So I have chosen this in this workshop, AI for responsible and sustainable environment, a futuristic model. So there is some echo is there. So I think can you reduce volume of one speaker? There may be multiple speakers.
Okay, sir.
And my perspective, yes, my perspective will be that mostly in the satellite-based image processing and future predictions of the sustainable development, particularly I shall emphasize on Sundarban predictions, and later on some AI tools being used in various aspects of the society. So why I have given this picture? Because you see, we are taking the satellite picture, not normal picture. That means that the satellite is the away from the surface of the earth. What is the distance? The distance means normally what we'll deal with this green type of satellite, that is around 800 to 1500 kilometer away from the surface of the earth. And this is a passive satellite where we have the sun is the source. And the same equation we are using. And you see, this is our footprint of India. Mostly all our Indian satellites is the IRS satellites. All of these IRS satellites are consisting of the footprints of Southeast Asia. So, and you see that when satellite is commissioned, it is a polar satellite. We are talking about the other satellites. I am not talking about geostationary other. These are communication networks and satellites. So I am talking about the polar satellite. That means it is a rounding around pole like this, and it is sweeping around 70 kilometers width in one row, scanning of one row, and you see that normally at 10 a.m. in the equator, it used to rise like the sun from the east and it go to the west. Something. So this is called the remote sensing satellite. And from the, you see, this is one satellite image, raw image, without processing the image. This is the main drive of Bombay. And now the total system, whatever we normally do in a satellite image processing, that you see sun is the source, and after traversing the surface of the atmosphere, sun is coming down to the ground, falling onto various creatures of the surface of the earth, suffering various scattering, radiation and all other, and again going back from the surface of the earth to the satellite. So now here you see, based on the suppose surface of the earth, it may be tree, it may be rooftop, it may be water bodies, it may be seas. So reflection pattern is different. I'm not going into details. So and then same you see, after crossing the equator on the other side, so it will just stop taking the data, because at that time at that side no light is there, and at that time data is uploaded to the ground station. So our processing is in the right hand side. You see, this right hand side we are processing all these things. So this is the system what we are using. So data is being processed offline in the ground station, and only the remote sensing satellite is that receiving the data. And then what we used to do, we used to detect some changes on the surface of the earth for our sustainable development, that some portion has converted from greeneries to the rooftop or some concrete road. So how it has been changed? When green is there, the reflection pattern, the trees are absorbing some frequency and transmitting some frequency. Rooftop absorbing some frequency, transmitting some frequency. So these are different. So based on that, these are called the signature of the surface of the earth. Based on this signature, we used to take the picture and interpret the data and the picture. And you see that I have this, it's called the atmospheric window, where we have various absorbent, that H2O, CO2, O3, something like that. And normally we used to go for infrared and near infrared portion of the spectrum for our remote sensing purpose. So the difference between a normal photo in your camera or mobile and the photo from a satellite is that there we have a very selective frequencies based on the sensor. So we are making the sensor based on our requirement. What is requirement? Suppose for the vegetation we have one sensor, for the snow we have different sensor, for the ocean we have different sensor, and that is why you will see that lot of different the name of the satellites and transponders and the satellite various sensors on the satellite. So you see that when we are doing the changes, these changes may be, just I can just discuss this change from here. You see, suppose one barn was there, so green vegetables were there and it is burned. So now if I use the spectral change, so if it is a healthy vegetation, so it will be green, the green curve is the healthy vegetation. Now after a long burn, you see that healthy vegetation gone, so only the burn areas, you see the frequencies will be changed and a different frequency. So and now I can detect the change from this two stage of satellite. That means today there is no burn and after 5 days there is burn. So I have to compare these two, that what was the pixel, now what is the pixel. It is called the change detection. And our goal is the change detection in sustainable development on the surface of the earth. Now we have some cautions for that. What is the caution? The caution that data to be taken homogeneously. That means you have to collect the satellite image. You see, I cannot get any satellite image for any day, any time, because if there is a cloud cover, so satellite image cannot be cannot be accepted, that normally throw away. And normally we used to collect the image in a similar time and of the day, same session, and normally nearly cloud free, co-registered with other and radiometrical and atmospherically correct. So these are done by the ISRO nowadays. So, and when we are trying to detect the change, we can go for visual analysis. We can go for image classification, just like normal image classification, satellite image classifications. I will show you satellite image classification, image differencing, and temporal trajectories. So like that, you see, you can see the visual interpretation to the right hand side of my slide. So various approaches are there. I am not going that. We used to see lot of images, and you see, we can go for the image that as a binary, as a metric, and we can change. We can take a difference of two images, and then you see, you can change this. You see, compute the difference between two images, and we can construct the image so that what is the change, I can detect that image. So now these are all classical process. But nowadays we are the era of AI. So AI governed process is to be initiated here, and we have done it and we have predicted it. We'll show you that. You see that what is the traditional programming, we have the program code, we have the input, and you are using a computer, and your algorithm will be compute to generate the output. But in machine learning, we have some input data, we have output data. Same data you can just categorize, you just segregate into two parts. Then you generate your algorithm, and then you apply your algorithm on the same type of data, so you'll get the same type of output. That means, you see, suppose I'm just giving an example in terms of AI, that a very classic example, that here a lot of characters are written. So I need to identify that character 2. So this first we shall take half of the 70% of this data as input and 30% as the output to identify 2 here. So 2 is written in different ways. So we definitely have to go for a training. So if we go for the training, so you see 2 is written here, 2 is written some here. Yeah, so a lot of other places 2 is written here. So it will be trained like this. And then, sorry, if you train the system or the model, now if you take an unknown data, it will give you the same output if you find out some characteristics of from that data. So what we used to do, we used to recognize the pattern, we used to generate the pattern, we used to recognize the anomaly, and you go for prediction. These are some of the process we used to go. These are various applications, web search, computational biology, all other social network we are using in various cases. Now, when I am talking about learning, I am not going into details of this. We may have supervised learning, that means training data and desired output, which is labeled data. If we go for the unsupervised learning, so training data without desired output. And in semi-supervised, training data plus a few desired output. And reinforcement learning, rewards from sequence of action. Just this is one unsupervised learning genome application. Yeah, these are unsupervised learning. Just I'm giving you, I'm not going into that. These are some of the picture. I'm not going into details. Now we have nowadays agentic AI and others for all of this, that normally we go for the reinforcement learning. So I'm just skipping all these things. So what is the main background of this Computation is that the neural networks and neural computations where we have the inputs, we have the weight vectors, we have the learning rules, and we are getting the output. So now, if we come into the environmental application of artificial intelligence, how we can go for it? I'm segregating all other normal applications. So here I'm going for a climate change prediction and modeling because this is increasingly used in the environmental case, and this will allow you a better understanding of the environment, and so that we can go a good mitigation plan. So reinforcement we have already. So let us consider change detection and future prediction. My title was there in mangrove of Sundarban. You see that it is a UNESCO bioreserve. We have 3 sections, or I can say that 3 sectors of the Sundarban area. Sector 1 is your normal Jharkhali area. Then middle area is sector 2, and intense and dense area is the sector 3. Now recently, various analysis are done for mangrove prediction and future prediction of the Sundarban areas. So here, what we have done is that we have taken the satellite image. What image we have taken? We have taken the image from the period 1975 to 2017. And the images are in 1975, 1990, 2000, 2010, and 2018. 1, 2, 3, 4, 5 separate images we have taken. I'll show you. And the objective is to predict and highlight on 2034. So these findings are reported in Earth Science Journal, Earth Science in Informatics in the SCI Journal, good journal. I'll show you the result. So how we have taken the data? You see, it is very difficult to collect this type of data since 1975. But we have collected, it's almost 1 year we have spent to collect the data only. We have taken the Landsat satellite 3, and we have taken 4 band from there in 1975. Again, we have taken Landsat 5, 7 bands in 1990. Then we have taken Landsat 5, 8 bands in 2000. Then again Landsat 7, 8 bands in 2018. These are the data. These are the actual data we have taken from the repository of satellite image. And I was talking about that image should be identically same time. So we have taken the image during November to January. Because you see, those who are going to see the Darjeeling and Kanchenjunga, end of October and the November is the best time to see. Because the weather is free from noise and moisture also, and cloud coverage is less. That is why. So we have taken the data from November to January. And we have taken path P138, row R45. So satellite is moving. So we have selected path for Sundarban. Now, what are the significance of this study? The significance of this study is that mangrove forests are visible in the intertidal region along the shoreline of surface in most tropical or semi-tropical zones. But these are the dynamics of the environment and habitat of wildlife. So you can monitor the vegetation, you can go for the land inventory and the rising of sea temperature. Now what methodology we have used here? We have used back propagation neural network with multiple hidden layer based machine learning algorithms, which is called the deep learning, as the basis of computation. And what are the frequencies? You see, we have taken the satellite image. So satellite image is not consisting of all frequencies. So we have taken red, green and near infrared spectrum from 1975 to 2018. So this network is trained on weight vector and we have defined some threshold and we have find out some optimal vector and ultimately we have find the optimal threshold. So this is one way to generate a better objective function. Then we have classified the remote sensing data. So what classification we have done? We have done classification on healthy vegetation, unhealthy vegetation, wetland and water bodies. And from there, we shall detect that how much one type is converted to the other type during the complete period of 1975 to 2018 first. That means first we shall analyze the existing data, whatever we have taken. Then we shall validate it. Then we shall go for prediction. Okay. So now what is the observation from the satellite data? These are computed that water body has gradually increased from 1975 to 2018. That is the first inference. We have taken the data from 1975 to 2018. So the water body has been gradually increased. The waterland has been declined from 75 to 2018. But it is not uniform. Particularly 1990 to 2000 it is increased again. I will show you. The result of classification shows that the forest area, particularly mangrove forest areas, are gradually declined around 6.83% during this entire study period from existing data. And part of the wetland flooded by water bodies due to rise in sea level. This is the observation of our study. Now, you may question that how do you validate it? Definitely, when we are using some AI-based data analysis, we have to go for some validation. So, in this study, we have validated using two parameters. One is called the percentage of accuracy. Most of us we used to go where we have achieved the 90.32% accuracy. And particularly for the satellite image processing, the kappa coefficient is one of the statistical parameters. Is very important for validation. We have received 0.86978% of kappa coefficient. If it is more than 82, it is good agreement. So both of these are almost perfect agreement. It is a very valuable tool, kappa coefficient, for any remote sensing processing. Statistical tool. Now, not only that, then we have gone for a modeling. We have the base data from 1975 to 2018. Around 43 years data we have taken And we have used cellular automata and Markov chain model. Now we have again gone for a mathematical model to simulate the spatial and temporal data of satellite image of Sundarban. What we have found? We have found that the accuracy difference of your machine learning, where we have used the neural network and CA Markov model, around the accuracy difference between deep learning technique and CA Markov chain, which is mathematical model, is only near about 2 to 4%. That means again what we were talking, that the accuracy percentage and the kappa coefficient percentage is perfect agreement. Now mathematical model is also confirming the same thing, that not more than 2% to 4% deviation. Minimum is 2, maximum is 4. That means whatever data we have taken from the satellite and whatever analysis we have done, it has perfect agreement based on the mathematical model and statistical accuracy computations. So now, based on that, we have given some inference. What is the inference? The neat forest area declined by 65.7 kilometers square, 2.89% during the period 75 to 90. Net forest area increased by 59.54 kilometers. You see, it was increased. I was talking about that 1990 to 2000. There was a mitigation plan, definitely, so that it has been increased. Again, it has been decreased from 2000 to 2010, 3.61%. And 2010 to 2018, again 2.95% decreased. So as a whole, 6.84% decreased forest area. That means you see this is a bioreserve and very important, plays a very important role, these mangroves. But still you see in 43 years, it has been degraded 6.84%, which is alarming. Now, you may say that you please quantify the, I have already quantified the changes, but what are the main region of the changes? Mostly the forest deforestation was seen along the river bank, small channels and shoreline of the sea surface. You see, in the Sundarban bioreserve area, there is no road network. If you go up to Basanti, after Basanti, there is no road network. Only river channels are there and deltas are there. We used to go visit to the Jharkhali area. There we have a tourist bungalow. Sector 1, we can build some infrastructure with the permission, but in sector 2 and sector 3, we cannot build any areas. So it is observed that net forest area gradually declining. So net effect is that the forest degradation as a loss of natural habitat and scarcity of fresh water, land erosion and global warming. So now some cause we have analyzed for deforestation. It might be change from other land use, that conversion of human settlement, that you are making some bhedis in Sundarban. That means you are cutting the mangrove and generating some bhedis. That is one thing. And nowadays you see this is contradictory remarks against the development, but UNESCO never allow that. That what nowadays we used to promote that you cut some area of the mangrove and you go for the growing of vegetables and growing of various types of fish to farm and agriculture, shrimp farm, which is called the shrimp farm. And you are going for over harvesting, grazing, fishing, looping and browsing. So it's reduction of split deposition, pollution, flood, coastal erosion. So all these things are happening. So development is going one side, destruction is going in other side. So we have to balance, we have to mitigate these two, definitely. Now what is the main place of effect? The significant change was observed on either of the outer periphery or near the shoreline caused by anthropogenic and natural forest. The rate of erosion is peak where? In the southern edge, in Mayadip, Balucheri and Bhangaduni Island. So these three islands, they have eroded maximum. And maximally, the erosion was among the banks of major river channels. Now, you see, whatever we have called, this is taking the satellite image and what satellite image is telling. We have extracted the information from the satellite image, nothing else, and we have validated. But now, our aim is to predict what will be the status of the Sundarban in 2034. Here, we have taken the year 2002 as a base of the transition probability matrix. So we have taken a transition probability matrix, mathematical computation, and primary matrix as a result of computation from 1975 onwards. It's okay? That means 2012 is the primary base of the transition probability and starting from 1975, and summarize the results of actual based on the received satellite image from 75 to 2018, and we have predicted in 2026 and 2034, ultimately 2034. You see, during 2010 to 2034, the healthy and unhealthy vegetation areas will be more lost, whereas the wetland and water bodies will be increased. It is obvious that the most of the forest will be lost along the river bank, and small channel in the southern and southern western side of the Sundarban, and some of the island may be more eroded, extreme edge of the Sundarban. So what is the projection of the outcome? Probably, so I cannot ensure. So probably based on all the model and validation, whatever earlier we have done, so we are predicting that around 12.89% of net forest area will be lost in the year of 2034. See, I was talking about that from 1975 to 2018, 6.69% it was there. Now in 2034, the loss will be around 12.89%. The wetland will be increased, the water body will be increased. Now I am just talking about the rate of the change, whatever you have computed through our mathematical models and the network model, that the rate of the change for healthy vegetation may decrease from 0.42 for the period of 18 to 2026 and minus 0.33 per year for the period 26 to 34. Now we have to go for some sustainable plan. So I was talking about the sustainable development and the plan. So some suggestions are there that you have to go for selection of cutting of the trees as per tree age. Proper measurement is needed for the fire plan of mitigation according to the regular basis. New plantation programs have already been initiated. Frequent monitoring of the forest. Audit of the forest is a very important issue where we mostly neglect. Editing of the forest, the area of the forest, and the status of the forest. So this auditing is very important with a very periodical manner. Some chemical spray is also needed for the sustainability of that trees and others. So government has taken a lot of measures, particularly find out the region where it is mostly deforested, or observe the use of forest products in a commercial purpose. How do you reduce that? So now government has taken some policies for development of national forest parks. You can see that lot of various national forest parks we are going to implement, so that there will be maximum restriction on the green destruction. And most important issue is to encourage the local people to build up the consensus, to keep the existing forest and to add up the greeneries. Now let's see the pictorial representation. You can find out all this. Yeah. You see, these are 5 satellite image you have taken. We have already told that one is 1975, is the 5/12 1975, 3/1 1990, 17/11 2000, 24/1 2010, 28 to 2018. So these were. And path row, you know that the position depends on the path row, and these are the bands, and these are the resolution. You see, all the satellite image has some resolution. What is the resolution in terms of the meter? 57 cross 57. 1 pixel consists of this, so that we can compute the area, destruction of the area. And this is the area we are considering here. You see, we have taken 5 satellite image. So this is the first thematic map of the first satellite image in 1975. This is the second satellite image you have taken in 1990. This is the third satellite image in 2000. You see, and this is the fourth in 2010. You see, you can see this particularly. If you check this one, you see it's being changed. It's being changed, you see, and these are being coming, you see. And here 2018. So last image you have taken in 2018. Now we have tried to compute the changes. This is the just satellite image we have got. Now the changes. You see, what are the changes? The water body has been gradually increased. The total forest area from 1975 to 2018 is decreasing. And yeah, so we have gone for image differencing. So your red color indicates the negative changes. You see, here this is 1975 to 1990. This is the difference. Again, if you go to 1990 to 2000, you see, red colors are increasing. Here less. Here also your red colors are increasing, but in 2010 to 2018, you see, lot of areas are getting red. Yeah. You see, part of the sparse forest converted to the waterland, part of the waterland converted to water body. So if you analyze from this satellite image, you can find out very easily that how the change legends are given here. You see, let us consider the detection of change in our Kolkata, where we are residing here. Again, it's 1978 to 2017. For the urban development and prediction of urban development at Kolkata, we have taken the satellite image from 1978, not 1977, 75, 1978 to 2017. So again, we have gone for the machine learning based detection, change detection and growth pattern in Kolkata. Here we have used the supervised maximum likelihood classifications. And we have classified urban built up, open land, vegetation, agriculture, water body. So in 1978 we have taken the image from Landsat 2. In 88 we have taken the Landsat 5. 2000 in Landsat 5 again. In 2000 Landsat 7 and 2017. It is 2010. It is not 2000. Is error. The typo. And in Landsat 8 in 2017. All we have taken as a multiple spectral band. Now what is the observation? I will show you graphically all these things. The change detection shows that 54.84% open land, 12.66% agricultural land, 7.19% water bodies and 5.10% vegetation were transferred into urban built-up area during the study period from 1978 to 2017. You can download the two papers. This is one remote sensing, Journal of Remote Sensing by ISRO, which has been published. Most of the open lands were converted to urban built-up area. Now, 9.04% water bodies are converted to open land. That means the water body converted to open land. How? I think you can understand. I am not going to explain that. 20.97% water body is converted to agricultural land. So pond was there. Now grassland was there. Somebody started the cultivation there. Then 9.68% vegetation was converted to agricultural land, and remaining were changes 3% during the study period 78 to 2017. Criteria we have already discussed. Now direction of the change. Which direction you have changes most? It signifies that on the northern and southern sides, the urban built-up area are more expanded since 1978 onwards. Only it was expanded north-south wise. That means towards Diamond Harbour and towards Barakpur. Later on, the urban built-up area in the eastern region have been progressively extended. The northern region was spread around 56.39 kilometers square. In the eastern region, in the urban built-up areas were slowly increased during 78 to 2000. At that time, eastern part was not increased, built-up area. And it was very quickly, extreme quickly increased during 2000 to 2017. So all eastern part of Kolkata, urban built-up area has been increased during 2000 to 2017. And when we are going for a future prediction on the same manner, I am not going into details again, we have already discussed on that. In 2031, urban built-up area will be increased by about 9.77% from 2017 to 2031. So the open land, vegetation, agricultural land will be declined during this period. So net urban built-up area may be increased. And as a result, there will be a loss of 73.85% open land. That is very, very alarming. So now what is the sustainability plan? The policymaker and the planner for monitoring and mapping the recognized area where the ecological balance would be there. Now, the growth is going on in an imbalanced manner. So that ecological balance should be revived. You can go for the special plantation program in the residential complexes. That has to be made the mandatory. You see the changes now. Here you see these are the data again on the Kolkata area. This area. You see, this was in 1978. This is this pink, this is built up area. This is the Ganga River. This is the Ganga River. And you see, this is west, Howrah. And this is east. So you see, from 1978 to 1988, after 10 years, you see this area is spread up like this. But again, it has spread up towards the east, slowly. Then if you go to the 2000, you see, this part of the Ganga, that is towards Howrah, it is also increased. But this part has increased more. Here you see, this part completely, you see, this part. So towards east we are increasing. But after 2000, you see, after 2000, you see in 2010, you see that this part is complete greenery has been destroyed. You see, complete greenery almost destroyed. That means on the Howrah area. And in the eastern part, you see here, it has been extended. You see, it was only this part in 1978. But now it has been extended complete, almost encroached complete area of the urban built-up area. Now in 2017, you see, this southeast area is completely encroached with the urban built-up area. Almost, you see, 89.34%. You can see some other picture from here. You see, the urban built-up area is increased in terms of the square kilometer. You see, this is the curve for the urban built-up area. And this is the curve for, you see, open land. How much open land is decreasing? You see, these are vice versa. It is increasing, urban built-up area is increasing, and open land is decreasing. And vegetation is also decreasing. Agricultural land less, decreased but decreased nowadays. You see, this is the detection of the change. So 1978 to 88 in 10 years. You see, this rate is, you see, decreased open land. This red part is your decreased open land. Yeah. You see how these open lands are decreasing. You see? So towards the east, it is increasing towards the east. This part is the Rajarat areas is increasing maximum. So this is a special distribution of the discrete decreasing. You see, eastern part it is mostly increasing. This is 2017. Yeah, this part major towards the east. So everyone knows that This towards the east, Rajarat is increasing, particularly built-up areas. And here again the same graph. You see? Now this is the prediction for 2031. How 2031? You see, again it will be increased. Yeah, up to 2031. We have taken the data up to 2017. These are real data. But this is the predicted data. So it will be more increased by 9.77% from 2017 to 2031. So we have used the CMRCO model here also for validated the data. Mathematical model we have also used to compute. You see what will happen in 2031 in Kolkata. Into 1971, 78, this was the urban built up area. And this was the water body. In 2000, you see that this is Howrah area, and this is, you see, north south area, it has increased. 2017, you see north south again towards the east, and 2031 we are predicting that whole eastern part will consist of urban built up area completely in 2000. Red one, you see, all of this part will be increased. Yes. So you see this urban built up area will be increased here. No, I'm skipping this slide, going to some other slides. Time will not permit. How much time I will get, Krishna? How much time left for me? 5 minutes?
Yes, sir.
Okay, okay. Just I am giving you some other highlights. You see that we have used the environment and sustainability of the environment. So now I am giving you some of the development in terms of road and transportation system. You see now in your car, you have the ADAS, automated driving assistance system, integrated into the car. Nowadays, number of sensors we are using in the car. So this particularly Kia and all other good models of every company, they have introduced ADAS system. What is ADAS system? That automated driving assistance system. It is integrated. That means it will be assisting the driver. Suppose, just I am giving you an example for ADAS. Now ADAS 2 is there in India. We have started the ADAS 2. Suppose two cars are going, both cars are moving 120 kilometers, and they are away 1 kilometer away from each other. Suddenly the front car reduces the speed to 80 kilometers. So you are in speed 120 kilometers. You cannot reduce your speed in that way. So your driving assistant will take the control over the driver, and it will reduce the car speed of the car based on the proximity of the car, so that the collision or the avoidance of accident can be done. This is your ADAS. Just one, very simply I am telling you. Another thing is, another one thing I will say, and then I'll just, nowadays you see that you have the FASTag on your national highway. Now, what is happening? We have some toll gates, we have some bar, you have to stop, pile up into the line. You have to pay from FASTag automatically nowadays. You have to go. So lot of delay is there, particularly if you come during the evening at Dhulagad and the Dankuni. After 9 or 10 in the evening, you will see what is the horrible condition. It takes more than 1 hour. So nowadays the union government has come out with a solution. What is the solution? These toll gates will be there. The camera will be there, enabled with AI, and sensor will be there. AI based sensor will be there. So no bar will be there. So the car will be moving dynamically without stopping in the toll gate. Now you say how the toll will be deducted. The thing is that the AI based system will detect your number plate and it will connect with the FASTag, and FASTag will take your money from your account. Now you may have question. The first question is your FASTag may not be good. It's not money in your. So what will happen? So if it is not successful by debiting from your account, it will send one link for 24 hours and it will ask for payment separately. If you don't payment, system is coming that some fine will be coming. So this toll system already started in 24 places in across the country. So within 1 year or so, within end of 26, I think more toll plaza will be like that. And later on, within 5 to 6 years, you will see that the GPS based device, when you are entering into the highway, your GPS tracker will track you, and if it is the part of the highway, it will start the billing of the highway. And again, when you are coming out from the highway, it will take out the billing and the difference will be taken as a distance and the billing will be accordingly. It will be a, you see the retrospective billing, how much you have gone, how long you have gone. Nowadays it is a fixed toll area. Dankuni then only pulse it. No toll, any in between, if car is coming, you cannot do anything. So this type of future transportation systems and monitoring is coming. These are all AI based systems. So I think I have covered that time with 5 minutes. So thank you very much for, yeah. So over to Krishna for, I'm just stopping my presentation. Now any questions if you have, I can go for it. Now I can open my camera because, over to you, Krishna.
Thank you, sir. From the audience.
Sir, good afternoon. Can you hear me?
Yes, please.
Can you hear me, sir? Good afternoon.
Yeah, please.
স্যার আপনি যে ডানকুনির ব্যাপারটা বললেন, ওখানকার পলিউশনের একটা বিপাকি তুলে ধরলেন অবস্থা, তো ওটাকে কোনোভাবে মিটিগেট করার জন্য কোনোভাবে কি কোনো প্রসেস সেভাবে কি নেওয়া হয়েছে এর মধ্যে বা কোনো কিছু?
না, আমাদের ওয়েস্ট বেঙ্গলে এখনো টেন্ডার হয়নি।
আচ্ছা,
এইটা ওয়েস্ট বেঙ্গলের বাইরে 25টা জায়গাতে ইমপ্লিমেন্ট করা হয়েছে। অলরেডি টেন্ডার হয়ে গেছে, ইমপ্লিমেন্টেড শুরু হয়ে গেছে।
আচ্ছা,
ওয়েস্ট বেঙ্গলে এখনো এই পার্টটা হয়নি শুরু। কিছুদিনের মধ্যে ওই অটোমেটেড এআই বেস নাম্বার প্লেট ডিটেকশন, it will be done within I think 1 year or so, it will be done.
স্যার অটোমেটেড এআই যে আপনি বলছেন নাম্বার সিস্টেম যেটা ইয়ে করছে না ওটা তো শুধু ডিটেকশনের ক্ষেত্রেই হেল্প করবে, তো সেটা ক্ষেত্রে সেটা তো বাকিটা তো অ্যাওয়ারনেসের উপরে ডিপেন্ড করছে আর কি, তার বিষয়ে।
না, একটা গাড়ি ওখানে আর স্টপ করবে না,
আচ্ছা
গাড়িটা মুভ করে চলে যাবে। ওখানে কোনো, দেখো 1 ঘন্টা যে আমি ডানকুনিতে দাঁড়িয়ে থাকি, আমাকে আর দাঁড়াতে হবে না, আমার কোনো বার থাকবে না,
আচ্ছা
আমি জাস্ট ক্রস করে চলে যাব। আমার সেন্সার ডেটা নেবে, নাম্বার প্লেট ডিটেক্টর ডেটা নেবে, এআই বেস সেন্সার এবং ডিটেক্টর দুটো মিলিয়ে আমার নাম্বার প্লেট ইউজ করবে, সেই নাম্বার প্লেটের সাথে যে ফাস্ট্যাগ আছে ফাস্ট্যাগটাকে ডিটেক্ট করবে এবং টাকাটা কেটে নেবে অটোমেটিক্যালি। আমার কাছে একটা এসএমএস আসবে, নো বেরিয়ার, এটা বলছে বেরিয়ার ফ্রি টোল।
আচ্ছা
আর এরপরে কতগুলো প্রবলেম আছে। কি প্রবলেম? না, তোমার কাটা হলো না, মনে করো তোমার টাকা নেই, তুমি ডেসপারেটলি টাকা রাখোনি, তোমার ফাস্ট্যাগ কাজ করছে না, তাহলে তোমার কাছে একটা লিংক আসবে। তোমার তো গাড়ির রেজিস্ট্রেশন নাম্বার আছে, সেই মোবাইলের সাথে ট্যাগ করা আছে রেজিস্ট্রেশন নাম্বার, একটা লিংক আসবে, বলবে 24 ঘন্টার মধ্যে তুমি পেমেন্ট করে দাও, কোনো ফাইন নেই। এবার যদি তুমি পেমেন্ট না করো, ফাইন হতে থাকবে আস্তে আস্তে, এবং এটা কিন্তু আরটিওর সাথে কানেক্টেড।
থ্যাংক ইউ
তো হ্যাঁ,
আচ্ছা
ঠিক, থ্যাংক ইউ।
আর কারো কোয়েশ্চেন আছে? স্যার আমি একটা জিনিস মানে আপনাকে একটু এনলাইটেন করতে বলবো। ফার্স্ট যে কাজটা আপনি দেখালেন ওই সুন্দরবনের উপরে, এই স্যাটেলাইট ইমেজ নিয়ে যখন কাজ করছেন, এই ধরনের এরিয়াতে মানে কাজগুলো করতে গেলে কিছু চ্যালেঞ্জেস আছে, যেরকম অ্যাটমসফিয়ারিক চ্যালেঞ্জেস, যেটা ক্লাউড কন্টামিনেশন বা এই পার্টগুলো, বা ওই টাইডাল যে প্রবলেমগুলো হয়, এইগুলোকে ওভারকাম করার জন্য মানে কিছু যদি একটু এনলাইট করেন।
আচ্ছা, যে এখন হচ্ছে যে প্রসেস ডেটা, স্যাটেলাইটের যে ডেটা আমরা পাই এখন, পার্টিকুলারলি আমরা তো ল্যান্ডস্যাট থেকে নিয়েছি, যেটা ইউএস এর স্যাটেলাইট, কিন্তু এখন প্রত্যেকটা সংস্থা তাদের ডেটাগুলো স্যাটেলাইট থেকে যখন নিচ্ছে, আমি একটা প্রথমের দিকে ছবি দেখিয়েছিলাম, দেখো ডান দিক আর বাঁ দিকে হচ্ছে যে ওই সূর্য আছে, সেখান থেকে আমি ছবি নিচ্ছি, ক্যাটারিং এর প্রবলেম আছে, ডেভিয়েশনের প্রবলেম আছে, এগুলো আছে। যে ইমেজগুলোতে এই প্রবলেম আছে, যারা এই রিপোজিটরিতে ডেটাগুলো রাখছে, ওই ইমেজগুলোকে বাদ দিয়ে দেয়। হ্যাঁ, আমাদের ওইটা আর করতে হয় না, এখন অল স্যাটেলাইট ইমেজ আর প্রসেস ইমেজ, এটা অল প্রসেস ইমেজ, মানে আমাদের এখন আর র ইমেজ পাই না। আমি যখন 90-তে কাজ শুরু করেছিলাম, তখন আমাদের এগুলো করতে হতো, মানে আমি সি দিয়ে করতাম, তারপরে জাভা দিয়ে করেছি, এখন আর করতে হয় না।
Thank you, sir, for your knowledgeable deliberation and your insightful ideas. I think we all have gained a lot and learned a lot about AI and machine learning, which will be the future tool for tomorrow. Thank you.
Thank you very much. So any question, Krishna, anytime anyone can ask me, you can give my mail to them, they can mail me, I can answer them.
Okay.
Okay. Thank you very much.
Thank you, sir. আপনার এই
Okay.
নিয়ম
হ্যাঁ, খুব বাজে, আমি গত 7 দিন একদম বিছানা থেকে উঠিনি আর কি। দেখে খানিকটা বুঝতে পারবে। হ্যাঁ, ঠিক আছে, আমি রেখে দিচ্ছি। হ্যাঁ, থ্যাংক ইউ, থ্যাংক ইউ।
ম্যাডাম লিস্টটা আসেন না কিছু, আমার কাছে একটা আছে, আমার কাছে একটা লিস্ট আছে। অনলাইন ক্লাস করে একবার আপনি অ্যানাউন্স করুন।
অনলাইন আছে ইজি ডক্টর ইজি
আপনি একবার নাম ডাকুন যে অনলাইনে যারা প্রেজেন্ট করতে তাদের এখানে প্রেজেন্ট করুন, আমি তাদের অনেকে আছে এখানে প্রেজেন্ট করতে, আপনি একবার নাম করে দিন।
Now we are moving to our technical session. Oral presentations, online and offline. So we are going now, and session will be chaired by Dr. Suparna Pal, Assistant Professor, Department of Chemistry, Tamil.
এখানে আপনি ঠিক আছে, আমি এটা মেলাইটি করছি। এখানে নেব না স্যার, ডাইরেক্ট এখানে নিতে চাই, কিন্তু অফলাইন গুলো আগে অনলাইন গুলো হয়ে যায়, তারপর আমি একটা সিস্টেম এখানে নিয়ে করব। তারপর অনলাইন করে যদি অফলাইন করে আমি একটু নিয়ে দিচ্ছি।
Science and technology. This is a paper presentation. Now, every presenting participant will get 7 minutes time for the paper presentation and 1 minute for discussion. I request all the participants to please maintain their time for the time for the session. So, the first participant is Dr. Biplab Ghosh, Assistant Professor, Department of Physics, Vivekananda College for Women. His topic is Engineering Atomic Coherence and Interconnect via Home State Cavity (EVD), a quantitative quantum resource theory.
একবার দুজনেই চলে আসুন, দেখে দিচ্ছি।
আমার পেন ড্রাইভ নিয়ে আসবো?
আচ্ছা নিয়ে আসুন, নিয়ে আসুন।
পেন নেই?
না, আমি এক এক করে নিয়ে নিচ্ছি।
Second participant is Dr. Basu Madhikari, present. Third participant is Dr. Rakesh Gomi. Fourth participant is Mukti Potwal.
তুমি একটু এখানে টেস্ট করো।
Fifth participant Dr.
আপনি আমাকে
Abhishek
মেল
Boshu.
এখন থেকে আপনি এখানে আছেন?
Sixth participant is Arvind Sheikh.
ম্যাম এদিকে এই যে মেল করতে হবে।
Seventh is Dr. Richi Sheikh.
হ্যাঁ হ্যাঁ,
আচ্ছা আমার তো নিয়ে দিন।
আচ্ছা ম্যাডাম এক এক করে অফলাইন গুলো আগে বলি, তারপর অনলাইন গুলো অনলাইন। ঠিক আছে।
Start